Last time we ended on this problem where we were given a function and we were asked to graph the function. It's a quadratic function, so it was a parabola. We saw that it pointed upwards. We found the vertex, the axis of symmetry. We found the y-intercept and the x-intercept. We also found where the function was increasing and decreasing in the domain and the range. I want to do one more problem like this. And then I want to give you a couple of graphs, and I want to see if we can come up with an equation for those graphs. So here's the second problem. Again, we want to graph each quadratic function, determine if it opens up or down by finding the vertex, the axis of symmetry, the y-intercepts, and the x-intercepts. Then we want to determine the domain and range, and we want to determine if the function's increasing or decreasing. So here's our function. F of x is negative 2x squared plus 12x minus 10. Now this is in the general form. F of x is equal to ax squared plus bx plus c, where a is negative 2, b is 12, and c is negative 10. Since a is negative 2 is less than 0, which means our graph is going to point downward. Let's find the vertex. The vertex is equal to the ordered point hk, where h is negative b over 2a, and k is the function evaluated at negative b over 2a. So let's find h first. So h is equal to negative b, so negative 12, divided by 2 times negative 2. Okay, so that's negative 12 over negative 4, which is a positive 3. So now we know the x value, or the h for our vertex. So let's erase this h and put 3 here. Now we want to find k. So we're going to plug in 3 into our function. So our function is right here. So it's negative 2, 3 squared, plus 12 times 3 minus 10. Looks like we're going to get negative 2 times 9, plus 30 minus 10. So this is negative 18, a negative 10, that's negative 28 plus 30. And we get 2 for the k value. So let's plot this point. This is 3, 2, so right here. And the graph is pointing downward. So we should expect this to be a maximum. Okay, since we know the vertex, we can find the axis of symmetry. Remember, the axis of symmetry is just the h value here. So let's write that down. The axis of symmetry is x is equal to 3. So we're just going to put a dotted line right here at x is equal to 3. And we're going to use that to help us draw the graph. Okay, the next thing we need to do, so we found the vertex, the axis of symmetry. Let's find the y-intercept and the x-intercepts. And I'm going to put over here what this point is, 3, 2. And this is x is equal to 3, this line here. So it doesn't matter which one you find first. I'm going to start with the y-intercept. Now remember, the y-intercept is when we set x is equal to 0. So just look at your equation and plug in 0. If you plug in 0, you're just going to be left with negative 10. So our y-intercept is 0, negative 10, which is way down here. Oops, sorry about that. Let me scroll back down. Sometimes my thing switches. So anyway, 0, negative 10 is way down here. I'm going to have to continue this a little bit. So this is negative 6. That is negative 7, 8, Let's say this is negative 10. So at 0, negative 10, I'm going to have a point, which makes sense. It should be down below the vertex because the graph is pointing downwards. Now remember that this graph is symmetric. So if we have a point here, it should be on the other side as well. Notice that 0 is 3 units from 3 here. So we need to go over 3 units and then down 10. So this point is 6, negative 10. And this point is 0, negative 10. This is all we really need to graph this function. But it doesn't hurt to find the x-intercepts as well. It'll give us a better picture. And sorry, that's not exactly straight, but it's hard to graph with this, this application I have. Okay, so let's find the x-intercepts. Now to find the x-intercepts, we set y equal to 0. In other words, we put this f of x, we make that 0. So 0 is equal to negative 2x squared plus 12x minus 10, and then we factor it. Notice that there's a greatest common factor. We can divide every single thing by negative 2. So let's do that, including 0. So 0 divided by negative 2 is 0. This would be x squared minus 6x minus 5. And we can actually factor this. Sometimes you can't factor it, so you would use the quadratic formula. But since this is factorable, I'm going to get x minus 5. I think it's factorable. Let's check. X minus 5, x minus 1. Well, that can't be it because then we would get a positive 5. So, okay, maybe this isn't factorable. That's okay. Let's use the quadratic formula. This will be the first time we've had to use this. So we're going to have x is equal to negative b plus minus square root b squared minus 4ac, all divided by 2a. And I'm glad that we get to use the quadratic formula because sometimes you'll get stuff that's not easy to factor. So even if it is factorable, you might prefer to use the quadratic formula. So the b is 12. B squared, 12 squared is 144, minus 4 times a times c. Well, a is negative 2, and c is negative 10. Okay, I just want to double check here. So negative 4, a, c. Okay. And then a, we said, was negative 2, so I'm going to put that down here. And now let's simplify this. This is x is equal to negative 12 plus minus square root 144. This is 8 times the negative 10, so negative 80 over 4. Now let's pull out a calculator. 144 minus 80 is 64. Oh, it is. So we get negative 12 plus minus square root 64 over 4, which is negative 12 plus or minus the square root of 64 is 8 over 4. Okay, and then we're going to get two answers. So we got x is negative 12 plus 8 over 4, and x is negative 12 minus 8 over 4. So we have x is equal to, if we add them, we get negative 20 over 4, and 8, negative 4, I see what I did wrong. Yeah, we're getting what I had expected. The thing, what happened was, and that's my mistake, when I was right here, I divided everything by a negative 2, remember? So this became a positive. This became a negative, but I forgot to make this one a positive. So it does factor. It factors into 0 is equal to x minus 5, x minus 1, which is what I'm getting here. Notice that negative 20 over 4 is negative 5. And here I've got -4/4, which is -1. So it did factor. So that was my mistake. And that's okay. You know, that happens. So we get that our two numbers that we go through are 5 and 1. So our x-intercepts are 5, 0 and 1, 0. So you can see that my graph doesn't actually go through those because I sketched this. It wasn't a perfect drawing, but now we can make a better drawing by putting these two intercepts. So we have one at 1, 0, which notice it's 2 units away. And because this graph is symmetric about this line, we go 2 units over, which does happen to be 5, 0. So now you can see the graph a little bit better. So let's see if we can sketch this. Now right here is the slope is very big, and we're gonna go through there, then down through here, so something like that. So the parabola is shaped sort of like that. And now we've graphed this. I want to clean up a little bit, because now we need to answer some other questions. So one of the questions was to determine the domain and the range of the function. Now again, just by knowing A and where the vertex is, that's enough information for you to find the domain and the range. Because number one, the domain for a quadratic function is always going to be -∞ to infinity. Because this function, it doesn't have any square roots or fractions, so it's not going to have anything we need to take out of the domain. As for the range, remember that this is negative, which means we're pointing down. And since we have a parabola pointing down, we're going to go down to -∞. And we found the vertex was 3, 2. And this y value is the highest y value we're going to have. And you can see that in the graph here. Here at 2, that's the highest y value. And this graph goes down to -∞. So the range is -∞ to +2. So that takes care of finding the domain and the range. Now where it's increasing and decreasing, again, you don't even have to graph this to figure that out, because you can see the graph. Well, because you have a maximum, you're going to be increasing from -∞ to the x value here, and you're going to be decreasing past that x value. And you can see it on when you graph it as well. So we're increasing and decreasing. Let's write these down. We're increasing from -∞ to the x value 3. And then we're decreasing from 3 to infinity. And like I said last time, some textbooks use parentheses, some use brackets. I think your textbook uses a bracket, and so in the homework you're going to put a bracket, but if you get it wrong, then just put a parenthesis here.